Okay, so we're working on evaluating piecewise functions and stating their domain and range. So a piecewise function is just a function that has two or more equations. So if you see right here, this one has two different equations of lines, but then its domain right here is the domain, and the domain cuts off each line to where the lines don't go on forever. So when you look at this graph right down here, it's like, oh, hey, this graph is in two pieces, and we would have to actually look at it to figure out what the domain or the range was. So it can be in two pieces or more than two pieces. But that's what a piecewise function kind of looks like. So it could also be something like when you see a graph, it could have like a part here and then straight over and then a part up. It could have jumps in it. So it could have like from here to here, and then it could have a space and be like that. There's all different ways that it could be. Okay, so evaluating piecewise functions are not too bad. So we're going to leave this function kind of hanging out so we can see it right here. So it says evaluate function f above when x equals 0 and x equals 4. Okay, I'm just going to go ahead and copy it here so I have plenty of room to write. You don't have to copy it down. It's in the little box right above us. All right, so basically, when x equals 0, when x equals 0, look at your domain, which is over here. X is less than or equal to 0. That works because less than or equal to, and it equals 0. So you're going to plug in right here, you're going to plug in 0 for x minus 2, and you get negative 2. So what that means is when x equals 0, the answer is negative 2. Okay, and now if we look at when x equals 4, okay, well, 4 is on this amount. 4 is greater than 0. That's true. 4 is not less than or equal to 0. So 4 is greater than 0. So that tells me we use this equation. So use this equation, plug in 4. 2 times 4 plus 1, we get 9. So if we write f of 4 equals 9, it means when we plug in 4 to the function f, we get an output of 9. Okay, let's try another one. Okay, so evaluate the function f of negative 2. This is the same as saying when x equals negative 2. So if we have our functions over here, I'm going to call this function 1, function 2, and function 3. Okay, so like parts, the pieces of the function, there's 3 pieces. So which piece we use when x equals negative 2? Well, we're going to use function 2. And the reason for that is because it says right here, you do it when x is greater than or equal to negative 2 and less than or equal to 5. So that means when x is between negative 2 and 5, well, negative 2 is greater than or equal to negative 2. So we're going to use function 2. And so I'm just going to write a little 2 by it, being like, hey, that's the one we're using. So we're going to plug in negative 2 into x plus 2. And we get 0 as our answer. Okay, let's try another one. Let's try f of negative 8. All right, so where would negative 8 fit in which function? So look at the domains. The domains are these amounts right here. Look at those. So which one would negative 8 be true for? It would be function 1 because x is less than negative 2. Well, is negative 8 less than negative 2? Yes. And if you look at this function, it only says 3. So when you get function 1, the answer is just 3. There's nothing to plug into. It's a constant function. We just say, yep, 3 is our answer. All right, let's try C, f of 0. So where would 0 work? Would it work in function 1, 2, or 3? Look at the domains to tell. Is 0 less than negative 2? Is 0 between negative 2 and 5? Or is 0 bigger than 5? All right, so 0 is between negative 2 and 5, so it would be function 2. So that means you're going to take function 2 as x plus 2. You're going to plug in 0. 0 plus 2 is 2. All right, on D, which function would we use? Which one works with x equals 3? Okay, so that would be function 2, and that's because 3 is between negative 2 and 5, so it would work. So we plug in 3 plus 2, and we get 5 as our answer. Okay, which function would work for E? 10. Okay, function 3 would, because 10 is greater than 5. So that's why function 3 would work. So it's 4 times x, and x is 10. So 4 times 10 is 40. Okay, and last but not least, which function would work for f of 5? All right, function 2 would, because it says x is, if you look over here, less than or equal to 5. Well, equal to would work. Equal to 5 would be good. So it's function 2. Plug in 5, x plus 2. 5 plus 2 is 7. Okay, so describing the domain and range, it's really similar to what we've been doing in the past. So let's just extend these on a little bit. All right, so if you look at the domain and range from left to right, it goes on forever to the left and forever to the right. So the domain, if it goes on forever both ways, is all real numbers. Okay, now the range, it does not go forever to the left and or forever down and forever up. It goes down to here. This is at -4, and keep in mind that's an open circle right there. Then it does go up forever. So it's y is greater than -4. It's not equal to because of the open circle. Okay, let's try another one here. So I like to extend them. So this is going that way, kind of to the left and down. All right, and this is going up and towards the right. So if you look at it, you look at domain, which is how wide it's getting to the left and to the right, it's going, although it's going down, it's going to the left, and it's going up, but it's also moving out towards the right. So it's going forever left and right. That's all real numbers. Now the range, look up and down. It goes down forever with this, and it goes up forever with this. So the range is also all real numbers. Okay, and finally, looking at these two, so if you look right here, this goes off to the right and up forever. This goes off to the left and up forever. So the domain is going to be all real numbers because it goes forever in both directions. Now the range, it doesn't go down forever, so look how low it goes. This is an open circle right here, and that's at 0, and then it goes up forever. So it's y is greater than 0 because of the open circle. If it was a closed circle, it'd be greater than or equal to. Okay, and last but not least here is this one. Look at where it goes. What would the domain be on this graph? All right, the domain would be all real numbers because it does go towards the left and towards the right forever. Okay, look at the range. Keep in mind this is an open circle, and this is at -3, and it goes up forever. What would the range be? All right, it would be y is greater than -3, not greater than or equal to because it's an open circle. Greater than because it goes up forever, not equal to because of the open circle. And so that's how we do domain and range.